Hello everyone. Today we are going to solve few simple examples related to one-dimension motion. So for this example, I have a guy who's doing his exercise. He's running down a straight stretch of road with an average velocity of 4 meter per second for 2 minutes. We are looking to find what is the final position of this person, taking in consideration that the initial position is 0. So from the picture or the supported figure we have, I have the details of the initial velocity, initial position, which is 0. I have the velocity. This guy was running through the exercise, it's 4 meter per second. I also been given that the time for the whole exercise was 2 minutes, and here is the final position we are looking for. Now, from the kinematics equations we know, and looking to what is being given to us and what is missing, the best equation to solve this problem will be the x final equal x naught plus v initial times time plus half a t squared. Okay, sorry about that. So let's try to fix these little twos. It's half, and here is a square. Now let's deal with the question to find our numbers. Now the initial position is 0. The initial or the velocity is 4. For the time, it's giving me in minute, and we don't deal with minutes. We should be using seconds. That's the international standard unit system. So it will be 2 times 60. That will make it in seconds. Now the last element here, that will be 0, because when it's telling me that the average velocity of this guy, so it's kind of like it's a constant velocity of this guy, so there is no change in the velocity. The acceleration will be 0. From simple calculation, that will give me 480 meter, the final position of this guy after 2 minutes of running. Okay, now let's try to solve another example related to one-dimension motion to help us understand or practice more problem. I have an airplane lands with an initial velocity of 70 meter per second and then decelerates at 1.5 meter per second square. What is the final velocity after 40 seconds? So if we look at this example, you can't tell me the final velocity is 0 because the airplane will stop. Yes, eventually it's going to stop at the end. But let's read the question carefully and try to visualize the situation. The airplane will touch the ground with this specific velocity, which is 70 meter per second. That will be the initial velocity of the airplane when it starts touching the ground at t0. Now, definitely it's going to slow down, so it's decelerating with 1.5 meter per second square. What we're saying here is we kept looking at the airplane for 40 seconds, and after 40 seconds, well, we expecting the airplane it start to slow more down, so it will be something below 70, but later on it will stop. But I'm not worried about 40 seconds. I'm asking you, after 40 seconds, what is the velocity of this airplane? So if we look at this example and try to test our knowledge with the kinematics equation, we should be using that the final velocity equal the initial velocity plus the acceleration multiplied by the time. This is our initial velocity. Now, the acceleration here, it's not, this airplane is decelerating. So I have to put the minus 1.5 because it's helping me to know that this airplane is slowing down. The change of the velocity is negative because it's slowing down. Within 40 seconds. So let's do some math here. And this will give me 10 meter per second, the final velocity of this airplane, or it's the velocity after 40 seconds from touching the ground, or when it's start landing. For 40 seconds, at the end it's 10 meter per second. The final velocity, which is something expected. The airplane will start slowing down. So as the time goes, the velocity will go less and less and less until stop completely. But as I said before, we are concentrating on only the first 40 seconds from landing. Okay? I hope you find this video useful and see you again with another one. Thank you.